Welcome back, students. In this question, we would be applying the concept of Sarrus rule in finding the determinant of a matrix. We're given A to B as 3, 4, 1, 0, negative 1, 2, 5, negative 2, and 6. So to find the determinant of A using Sarrus rule, what you need to do is, foremost, you need to write the elements of the matrices in the form that I am showing you here. 3, 4, 1, 0, negative 1, 2, 5, negative 2, and 6. After which, you need to follow it up by writing the first column. That's going to be 3, 0, 5. And then the second column, which is going to be 4, negative 1, and negative 2. Now, to find the determinant of the matrix, you are going to be following the flow that I'm going to show you here. So what we do is we start with the element 3 and then multiply it with the element 1 and end by multiplying the element 6. Open the parenthesis. Place a positive sign. Again, now you start with the element 4, multiply it with the element 2, and then end with the element 5. Place a positive sign. Now you start with the element 1, multiply it with 0, and then you end with the element negative 2. Close the parenthesis, and then immediately you place a negative sign. Open the parenthesis. Now go to the leftmost extent where you can find the element 5. Start by placing the element 5, following it up with the element negative 1, and then you end with positive 1. Now you place a positive sign, and then start off with negative 2, multiply it with 2, and then you end with the element 3. Place a positive sign, start with 6, multiply it with 0, and then you end with positive 4. Now you need to evaluate all the elements. 3 multiplied with negative 1, that's going to be negative 3. Multiplied with 6 is going to give you negative 18. 4 times 2 is 8. 8 times 5 is 40. Of course, this is going to be 0. Following it up with a negative sign. 5 times negative 1 times 1, which is going to be negative 5. Negative 2 times positive 2, negative 4 times 3 is going to give you negative 12. Of course, this is going to be 0. So this is equal to 40 added with negative 18. 10, 2, 3, take away 1 would give me 2. So that's 22. Negative sign. Negative 5 added with negative 12 would give me negative 17, which is nothing but 22 positive 17, which is equal to 39. So therefore, the determinant value by Sarrus rule gives me an answer of 39. Now the question depends is, what happens if I were to expand this by Laplace expansion and see if I am getting the same answer? That would be quite interesting. So I start off by using the Laplace expansion. So let me do that here. So using Laplace expansion, okay, there's a simpler way to do that. I've already shown you in the classes before. So I start with a positive sign, open the 2 modular sign, leave all the elements along the row and the column. You get negative 1, 2, negative 2, and 6, a negative sign. Place the element 4, leave all the elements along the column and the row. So you got 0, 2, 5, and 6. place a positive sign and the element 1. Leave all the elements along the column and the row. So that would give you 0, -1, 5, and -2. Expand the elements 3 times of -1 multiplied with 6, negative sign, and -2 times 2, followed by a negative sign and a 4, open the parentheses, 0 multiplied with 6, a negative sign, 5 multiplied with 2, following it up with a positive sign with a 1 there, and 0 multiplied with -2, a negative sign, and 5 multiplied with -1. Simplifying, we would get 3 times of -1 times 6 would give me -6. This would give me +4. -4 times. Now 0 multiplied by a quantity would give me 0. So that would leave us with -10. +1 times of 0 multiplied by any quantity would give me 0. Negative times negative would give me positive. Rewriting this, I would now have -6 because -6 added with 4 would give me -2. That has to be multiplied with 3, giving me -6. Negative times negative would give me +40, following it up with a +5. Now 5 added with -6 would give me -1. That has to be added with 40, giving me 39. Now clearly, if you were to say, in this case, the determinant value that we have received is 39, and that agrees with the determinant value that we have achieved here using Sarrus method. So this completes this question.